Alright guys, let's do vodcast 7.1. We're going to start a new unit. This new unit is on naming compounds and doing the opposite of that, which is taking the name and finding the formula from it. We've had several things this year where you've read a name or seen a formula. You didn't know what it was called. You wouldn't have known how to get the formula from the name. And so in this unit, this is where we learn all of that stuff. And of course some stuff about reactions as well that we'll get to at the end. So we're going to start off by naming ionic compounds. Okay, so few quick notes, okay, nothing massive, but a few definitions that we need to know. So we're going to start out naming what are called binary ionic compounds, and all that means is that it's got just two elements in it, okay? So just two elements, meaning that we're not going to do the polyatomics initially. We're going to get there in a little bit. So that means we're going to be working with monatomic ions, okay, so they come from a single atom. Okay, not more than one atom at a time for a particular ion. Now, obviously, if it's a compound, it's going to have more than one atom, but each ion is only one atom. Okay, so first off, we've got our cations. Remember that cations are positively charged. Okay, so keep that in the back of your mind there when we're working through these, that these have to be things that are positive charged. And they're real easy to do. I mean, they're just referred to by whatever their element name is. So, for instance, if I have a Na plus, okay, that is called a sodium ion, okay? Nothing changes about the name. It's just whatever its element name is, okay? So if we have a Ba with a 2 plus, because we look on the chart and see that it has a 2 plus, that is very simply a barium ion, okay? So nothing too complicated about the way that we name them. This easy way is going to be true for everything in group 1 and 2 on the table, and then aluminum, silver, and zinc. Now the reason for that is that we always know what the charge of those things are. If you look on your periodic tables, you've got all that stuff marked down, so we know what the charge is. Okay, that is in contrast to multivalent cations. Okay, now we've talked a little bit about this word before, multivalent. Basically, this just means that it can have more than one charge. So if we looked at our table, as far as what we've done so far, we know that everything in the first column has a +1, everything in the second column has a +2, okay, and then other stuff over here, but it's not metals. And we know that aluminum is in this row, so it's got a +3. I'm not sure if we talked about this before, but silver always has a +1, and zinc is pretty much always going to have a +2 also. Those are the ones that we always know. The ones that we don't know is everything else, all of the other metals. So what is all of the other metals? So everything in the P block, okay, over here underneath the staircase. So remember, the ones touching the staircase are metalloids, but all the ones underneath that are metals like lead and tin, okay. Everything in the D block, okay, except for those ones that I've noted here, all right, and then everything in the F block as well. Those are all multivalent. And what that means is that they can have more than one possible charge. And we'll see here in a second that that's going to complicate things for us a little bit, because if we don't know what the charge is, then usually we have to figure it out. Okay? Now, so how do we name them, though? We name them by writing down their name. So Fe is iron. Okay, so that part is easy. And then in parentheses, okay, so in parentheses next to it, we put its charge in a Roman numeral form. Now, you may hear, if you take some further science classes, you may hear that it says oxidation number, and that technically is true also. We would put its oxidation number in here, but charge is what we're going to use most of the time. So iron 2 plus becomes iron 2. Iron with a 3 plus charge becomes iron 3. Tin, or SN 4 plus becomes tin 4, or tin IV. You need to know the Roman numerals. I'm kind of assuming you guys know those. If you don't, I put them here on the slide, so stop and copy those down. Make sure that you know those. I think most of you all recognize those pretty easily. Okay, so that was the cations. For the anions, okay, now remember, anions are things with a negative charge, okay? You name them in somewhat the same way. You start off with what the element is, but what you're going to do is you're going to lop off the end of the name, and you're going to change it to IDE. The anions in ionic compounds, in binary compounds, always end in IDE. We'll see that when we do polyatomics, they're different. So if we were doing the F minus that we've got right here, okay, F minus obviously is fluorine, okay, but we're going to take the back part of the name off. Okay, so that part, we're going to get rid of that. Okay, and we're going to change it to IDE. And it becomes fluoride. And that's how fluorine becomes like what you know in your toothpaste as fluoride. That is going to be true for all of the binary of the monatomic anions. So if it's got a negative charge, it's always going to be the second thing in the name, and it should have an IDE at the end. So oxygen becomes oxide, okay? Sulfur becomes sulfide, okay? These are all going to start to make pretty good sense. Bromine becomes bromide. Okay. Hydrogen's sort of a special case. Hydrogen typically forms a +1 charge, but it can form a negative charge, and so if it does, we would call it hydride. Okay. I didn't list all of them. There are still some more there, but if it's selenium or something, you change the name and it becomes selenide. Okay, so nothing terribly weird there. You're just going to change the ending to IDE. Okay, so that leads us then into actually naming them. So how do we name them? All right, so Na is sodium, okay? And then Br is bromine, and remember we changed the ending, so that becomes bromide, okay? Sodium bromide. And that's really all there is to it, okay? I don't ever have to really worry about subscripts, so like if I had something like this that was Na2O, okay? That's still sodium, okay? And it's oxide. I don't have to worry about the number here. The only thing the number is ever going to affect is the charge. And since I already know what the charge on sodium and what the charge on oxygen is, I don't have to include it, okay? And in fact, you'd be wrong if you did. That 2 doesn't come into play in the formula. So our next one here, we've got calcium, okay, and oxide, okay? So simple enough. Naming binaries is pretty easy as long as it's the stuff that's not multivalent. So here comes the killer. What happens when it is multivalent? Okay, what happens when I don't know the charge? So here's what happens. I know that this is iron, okay? I also know that iron is multivalent. It's in that area, okay, of the table that I'm not sure what its charge is, okay? And we already saw on another slide that it could be 2, it could be 3. I don't know which one it is. And it's real important that I do know which one it is. I have to indicate what it is, okay? So here's what we do. I write down iron, I put parentheses. Those parentheses are where we're going to put the charge. We're going to have to find it, and we'll leave that for just a second, okay? So iron, we're going to open up parentheses. I already know that the next thing is chlorine, and I'm going to change the ending of it to chloride. So it's iron something chloride, all right? And so now we have to figure out the charge. So that's kind of the hard part for most students. It's not really that bad, though, because we know that the charge on chlorine is -1, right? And so we're going to find the charge, much like we did oxidation numbers. The charges always have to balance out to be 0. That's how we did the crisscross method before. So 3 times -1 gives me a -3. I've got 1 iron. So that leaves me with an algebraic equation of x minus 3 equals 0. So that means x equals +3. And so the charge on the iron then is a +3. And so we come down here to our parentheses and we write Roman numeral 3. Okay? I'm going to do one more of those because that is usually one of the sticking points for a lot of students. Okay? So Sn is tin. That's a hard one sometimes for a lot of students. And again, tin is in that area that I don't know what its charge is. So anytime you don't know what it is, anytime it's multivalent, I have to put parentheses. Okay? Next thing is oxide. All right? And so we got to figure out what that charge is. Well, we know the charge on oxygen is always -2. All right? 2 times -2 gives me a -4. I know that it has to equal 0 to balance out. I know that I've got 1 tin, so that's x. So x equals 4. So I put Roman numeral 4 in there. Okay? So relatively straightforward. Okay? We'll have to work a few of those just to make sure that we know how that happens. But once you've seen a few of them, you should be all right. So if we're trying to find the formula, so like that was, I was given the formula, I had to find the name. That's actually the hard part. Usually if you know the name and you have to find the formula, this is actually the easy part. Okay, so here's the way it works. Calcium, okay, write down the symbol. Fluorine, write down its symbol. Go to your table and figure out what the charge is. Negative for fluorine, 2 plus for calcium, okay? And then we're going to crisscross it just like we've already done. So 2, 1, and so my formula becomes CaF2. Easy peasy. Okay, so for the next one, we've got iron, and I've got oxygen. I know from the table that oxygen's sign or charge is 2 minus. Iron's, I don't know because it's multivalent, but it's given to me in the problem. It has to be. If it's not, then you can't do this. So crisscross, 2, 2. So we kind of get Fe2O2, but we know that we have to reduce those for ionic compounds, so that becomes FeO. All right? So that's how you get the formula. It's pretty simple. That's binary in a nutshell. For ternary compounds, they're pretty much, they work exactly the same way. The only thing that's different about them is that they have got polyatomic ions. Okay? Doesn't change the way we did it. You're still going to crisscross them. If you're given the name and you have to find the formula, you're still going to crisscross it. If you're given the formula and you have to find the name, you're just going to name what the parts are and find the charge if you have to. Okay? So let's work these out real quick. So sodium is Na+, nitrate is NO3 with a minus. Now here's the one important thing. When you're working with polyatomics and you got to crisscross them, put the polyatomic in parentheses. Okay, so that brings a 1 down here, brings a 1 down here. Now we can drop the 1s. We don't usually write 1s when we write formulas, so that becomes NaNO3. Okay, and then to find a name given the formula, again we've got tin. I know that tin is multivalent, so I need to find the charge. SO4, and this is why it's really important that you recognize the polyatomics and know what they are. SO4 is sulfate. Okay, what's the charge on sulfate? It's 2 minus, and why is that important? Because I need to find the charge on tin. I have 1 sulfate. Don't let that 4 trick you. I don't have 4 sulfates. I have 1. SO4 is sulfate. Okay, so it's got a -2. Tin is the X. Solve for X there, and that means that we have tin 2 sulfate. All right, we're going to walk through a bunch of these in class. We'll do a lot more examples, but this is basically how it works. It's not much harder than this. And really, this is the hard part of naming. You get this, and everything else is relatively simple.